Hi everybody, very good afternoon. This is Krishna here. I'm working in Edureka for past 2 years, close to, and I particularly teach Python programming, data science, and Django, all that. And with respect to my industry experience, I have close to 15 years of experience, and I worked in service, product, and startup as well. And currently, I'm working on the cloud side, mostly cloud computing. I work on the AWS side of it. So that's more about me. So let's start our session then. So this is our topic for today, COVID data direction using data science. So I hope you guys are very well aware of data science and all. So I'll not be talking much about it. Now CNN. So neural networks is also one part of artificial intelligence. So let me give you a high level picture of what is this so that when I talk about it, it should make sense to you. So if you consider this as your artificial intelligence as a circle, so artificial intelligence is actually, you can consider subject or whatever. So basically artificial intelligence is a branch of science which actually tries to target machines to think like humans. That means main objective of artificial intelligence is how to make machines think like humans. When we say think like humans, we have intelligence, we have smartness. While we are walking, we know how to walk. If there is a pit holes and all, we know how to jump. Or if you feel some smell, you know whether it is good one or bad one, or you know how to taste particular thing. These are all things we get. How? We have been trained for years and years by our parents, by our relatives, whatever, right? So the training on all already happened. That's why we are so intelligent. That's why we are smart than any human being. Okay, I'm not sure if you see the National Geographic channel. The one thing they talk about is humans have so many intelligence. That's why even though we are more powerful than the animal world, the wild world, if you see, we are still able to capture them because we have that much smartness. So all this we obtain from a lot of years after being so many trainings and all, right? So the artificial intelligence is how to make devices or machines do like that. When they say machine, don't think it is always computers. That machine could be a simple device. It could be your phone. It could be, these days you're seeing Alexa. It could be any device which, it need not be a computer always. That's the whole concept of our AI. In AI, if you look at, there are again one more branch which is actually called machine learning. The machine learning part is actually dealing with all the set of algorithms. When I say algorithms, you can call it as programs. Algorithms is more of a pseudocode version. It is a free form language. There is no particular programming language as such. It is like if I want to write print something, I can just say print. I can start with start, then I will say print hello, then I will say end. Maybe if you want to write the same algorithm, you can start with begin, then you can say display hello, then you can say done. It's up to you. You're free from, you can use anything which makes sense. So algorithm is more of a not a representational but formal language. And when you say machine language, so these kind of algorithms which actually help to make computers or machines think and do something more of a prediction side of it is what those algorithms comes in ML. So ML is more about you understand about a lot of algorithms that actually help you to predict and forecast certain things. And again, in one part of ML is what your deep learning is. So deep learning whole objective is more about close to your AI, which actually ensures that, which actually the main objective is to make computers think like humans. How do you make computers or machines, anything? In fact, can you tell me a real world example of machine learning products we have today? Any machine learning product, not just deep learning, any machine learning product we have today that is considered as intelligent? Any idea? Any products which are able to do this stuff intelligently? Alexa is the best example. Alexa have got lot of ML embedded in ML. Also you have lot of things: natural language processing, image processing, deep vision, whatnot. Alexa, whenever you say Alexa and you say hi, so okay, so as soon as you say hello, what it does is it actually takes what you speak, and internally in Alexa there is a synthesizer, or you can convert it as a translator that actually converts your text to your speech to text in the text form, and that text is further processed by an NLP model, a nature language processing model. When I say model, it is a program. That guy will actually tokenize it out and understand what does it mean, and based on that it respond back, and it all happens in milliseconds. Okay, it is not like something I said and suddenly everything they have keyword like they have mapped, nothing like that. It's all processing, and they train it. I'm not sure if you get aware, before even Alexa release, they do some kind of beta testing where they will give to all the internal employees of Amazon, because Alexa is Amazon product, and they will ask them to speak to it daily, on a daily basis. And it learns. Over a period of time, it learns. The difference between a normal program and a machine learning program is normal program just works on the input you're given and just does a job. That's all. It will not learn anything. Whereas with machine learning, the advantage is it will not only learn, but next time when you ask, it can even predict based on, if you ask it to learn, like let's say you have given a data of last 5 years of customer sales, not customer sales or product sales, and if you say that what would be my sales in next 2 years based on your last year data, it can predict also. That means it understand the patterns from those 5 years sales and try to infer conclusions or try to get insights on how those next 2 years or 3 years can be based on what it learned. So it's all about data. AI, data science, machine learning, deep learning, these all guys needs a lot of data and correct data. If you are passing wrong data, wrong insights. Correct data, correct insights. It's all like that. So the more and more you pass the data, the more and more it gets improved. It is as simple as us, right? If you have been trained so badly that we don't know how to walk, right? So you can see, you might have seen this movie, right? Mowgli and all. If you see in that movie, he has been trained in, a jungle where there are like, he's been trained in, in the environment of full of animals. Now, what would happen? He will also behave like that because he has been trained like that. So what I'm trying to convey here is it's all about how you're being trained. So if you have to train with the right data, it will act rightly. So it is all like that. And deep learning, like I said, it's more about thinking how to make your devices think like humans or programs think like humans. That's the whole concept of it. And when you look at it, how do we think is internally in our brain? That's why we have put a diagram. There are a lot of neurons. Neurons, there are a lot of neuron cells actually is responsible for doing everything. Like for example, let's say I'm teaching you webinar, right? I'm looking at something. So my eyes are my input there. My eyes are input there from which I actually using my vision, I'm able to grab what I'm seeing, and that response goes to my brain, and there is some set of neurons who is responsible for it and process it and say that, okay, after you look at it, this is how you should feel. If I like the movie, let's say Jackie Chan movie or comedy movie, I might smile or I might be focusing very keenly. That is my response. That's exactly what they do. And here what we are trying to say is we just put one of the neural network. When we say deep learning, the deep name is come just from how deep these layers are. This is your hidden layers actually. So since we have some background on this neural networks and deep learning, see, deep learning is more about making computers think like you're human or devices. So when you say computer, don't think computer means it's always your the laptop or your desktop machine. No, computer means any machine which is able to take your input, process it, and do kind of some kind of storage and all that. Even that also you can call computer. In fact, your calculator also can be called as computers. If you deeply look at the Wikipedia definition of computers, they never say your laptop or desktop is the only computers. Just that we have been taught in a maybe different way, so that's why we are all thinking like that. Now coming to our subject, now what is this? This is an artificial neural network. And believe me, most of neural networks, at least with respect to my experience, they have three main components. One is your input layer, another is your output layer, and in between there are hidden layers. These are the three main components. If you take either ANN, CNN, RNN, which is called artificial neural networks, convolution neural networks, or recurrent neural networks, everybody has this set. Now, what is this input layer is? You can assume this input layers, everything is a neuron here. You can assume this input layers is like I said, when I'm seeing, my eyes are my input. Those are these input layers, you can understand. And this is inside your brain. You can understand where it do some kind of processing. And response. When I see, I might laugh because if it's a comedy scene, or I might be focusing very keen on the movie because I like that action movies. So that is my response. So any neural network will have this. So the design architecture also they have made keeping in mind on how we behave. So this input layer, I'll not talk too much technical because that needs a lot of discussion on these particular how the weights and all coming, but I'll give you a sense of so that at a high level you understand how things work. So this input layer is where you actually pass set of data and it actually sends to multiple neurons, and each neuron is responsible for multiple things. Like for example, if you see F, these are all means activation functions. So there are multiple activation functions. If you look at activation functions, there are bunch of them. like starting with activation networks like ReLU, and you have some of the inactivation networks like there are too many of it. Like if you search in internet, you will find at least 10 or 15, and ReLU is the one which we might be commonly seeing. That does not mean those are the only one available. There are like bunch of it, and here in our exercises also we are going to use activation function called ReLU. The difference, what actually these activation function is, you can consider this is like a mathematical function. The activation function is simply a mathematical function which actually we use, and those are all proved hypothetically that this will give this result and all that. Okay, now coming to this one, so like I said, there's an input and hidden layer. So you pass some input and there is a weights associated to each input. Further, there will be like a weighted summation, sigma means summation, and it will pass to mathematical function. Like some mathematical function, if we consider like humans, may be responsible for our smell, or some mathematical function may be responsible for our vision. Some mathematical function may be responsible for taste. So you can consider each of them as a neuron which is responsible, and based on that, that particular activation function or whatever will react based on the inputs you get and give you some output or give you some response. This is the overall point of how this actually looks like. Okay, now this is what it is. Like you see, there is a car image I have passed to it, and think how you think actually in your brain. There will be like multiple neurons connected in a this kind of topology where there are multiple neurons react. So when you pass this input internally goes to multiple neurons, and there will be different neurons that might understand how this picture looks like based on the size, based on the dimension, based on the features like the color, or based on the shape, or based on the the way it looks like, all that. So it actually, there are multiple neurons because we are already trained to look at these kind of cars and we realize this means a car. And finally your output will be a binary classification. When I say binary classification, the binary classification algorithm is more about yes or no. That means here you are saying, is this a car or not a car? That's being the output. So this is how it generally works on ANN. Now why you have to use CNN here? So if you see, one problem with the ANN is, let's say if you train your machine using ANN, and let's say this is the image trained, the biggest problem with ANN is it remembers about the everything about which pixel it is and all, and it thinks that every time the image will come into the same problem and all. But let's say if you move your image to somewhere else, get confused and might not give the expected results. That is one problem with ANN neural networks. And one more, if we look at deeply, there are other problems also. Performance wise, ANNs are not as good as the other neural network algorithms. And maybe when you don't have a lot of knowledge about the system, maybe ANN might work good, but you cannot, if you have lot of data and you have lot of data that actually help to train the machine, this is not a good one to pick it up. Okay, this will only work when you have a very limited knowledge about your system and you want to train it with a limited data. Maybe this might work, but not everything. Okay, so that's the whole concept behind it. So now coming to what is CNN. CNN stands for convolution neural network. So again, like I said, everything has its input layer, a set of hidden layers, and you have set of output layers. That convolution neural network, that convolution is nothing but the convolution layers which are part of these hidden layers inside. And if you look at how this will look like, is when you pass an input, inside there will be a convolution plus there will be activation functions. Then you have something called pooling. You can see that pooling also here. Is it not mentioned? No, it's not mentioned here, but there will be a pooling also. Then after that, each neuron, there will be multiple layers, right? There will be multiple. Here you see convolution, here you see convolution. These are all layers, or you can consider different activation functions that get reacted based on the input you pass. Like here, the understanding here is, if you write a number 3, how do you make computers understand that's a number 3? See, I can write number 3 like this. Maybe if you are a good writer, you might write like this, or somebody will write even like this, or somebody will write like this, or somebody will write something like this. Now different, all these are number 3 only. Now how does computer understand this is number 3? So you have to train your machine with lot of images which are of different shapes and all, so that it understands its feature and all. So for that, internally it has lot of layers, or we can call it as convolution layers, which actually does the job of doing all this. Okay, and it internally have, if you look at the high level architecture of it, uh, I'm not sure if we have put that here. Let me see. This is what I was talking about. If you see here, aircraft sensing input, this is my image, and there is a convolution plus ReLU layer. So ReLU is your activation mathematical function. the hidden layer, there is a F in the first diagram, right? That one. And there will be pooling, and then again there are, and again, convolution layer. So each time what happens, if you see, the boxes also getting smaller and smaller. So overall, from a big image, it tries to understand your, and finally it flattens it, and finally it gives you a reminder, it gives you answer that whether it is a aeroplane image it is able to deduce or something else. So it will able to tell. Okay, that's the whole point. So we'll see about what is this convolution, what is this ReLU, and what is this pooling and all. And there is something called padding also, which is not mentioned. That is also part of this. Now, what is convolution? So convolution, if you see, observe this image. It's like your convolution is like this. Your input, this is like a, it's like a filter in between that actually sits, between your activation function and your input. And that is the guy actually maps, it's like a mask, and based on that, the relevant activation function will get triggered. Okay, that's how the activation. So you can consider convolution is like a filter. Now coming to padding, padding is like when you actually, what will happen is when you filter it and after that you get some data in terms of images. So why we are saying all this, first of all, is I'm not sure whether you guys are aware, image at a bottom level, if you really look at, it is nothing but numbers. It is nothing but a set of numbers of RGB values, or I can say set of RGB pixels. Pixels are means what? It's numbers at a bottom level. So all those RGB values, when I say RGB, it is red, green, blue. Any image can be represented using these three colors, right? So this set of all these RGB pixels, if I put it, those are nothing but my numbers. In fact, they are all matrices, different matrices. That's why we are showing all these numbers. It's not like we want to show you some animation kind of. This numbers is nothing but some image data. And in that you have a filter, which is your convolution, and that actually comes in between. And using this filter is what that relevant activation function will get triggered. And when you say image, when you actually get the data, sometimes some of the padding is the one where you need to backfill some of the data, because whatever the data you obtain while you are processing the image as part of a particular neural network, maybe that might not have all the pixels required. Some of the pixels might be empty during the processing in between. So those kind of pixels, if you want to backfill, that is what called as padding. Padding simply refers to backfilling the pixels which is left over or left, those kind of things. So that's padding. That's what we call. And in fact, in your programming language also, whether you're not aware, when you're using this printf statements, sometimes you do padding also. There we will not call padding. We will call similar term, but it actually means you will fill with some spaces and all. When you put a tabular format using print statements, you will actually do some padding just to align your data in center. That's actually called as padding. Okay. Now, what is max pull is, once you actually, over the period when you are doing this neural network, all that using whatever algorithm, whether it is ANN, CNN, or RNN, you will get different set of matrices. In that, what would happen is, in max pooling, what we do is, using max pooling, you actually tries to find the largest values in that matrices. Like for example, in this, if you take this 3 by 3, in this the largest values are 9, 5, 6, like that. So that is the largest values, you pick it out from here, each of the image when it is filtering. So that is the point, because why you have to pick the largest value is, the reason is, if you take the data, not everything you can give it in the same form, because when you actually want to, what is being observed is, if you take the maximum values of the pixel, your image resolution will be, image will be able to display more horizontal lines or vertical lines, like that. There are a lot of contrasting can do by taking the maximum values. That is also possible. So that's why we use this technique also as part of the convolution networks. Now here you see max pool, like I said, you see that here 7387, in that it is picking the maximum values 8699. So max pool is nothing but just getting the maximum value on each of it. And this is all we don't need to do. The algorithm internally do. We are just understanding how these things happen. Okay, these are the terminologies we need to be aware. Now let's look at our small presentation. So I have this, COVID-19 data set, where, let me connect to my collab. Once it connected, we can start looking at it. And what I have actually did is, I actually downloaded. So my idea here is, I should be using whatever algorithm. Here I'm using CNN. Using that algorithm, yeah, I'm ready. So using that algorithm, I should be able to say whether a particular X-ray. So X-ray images I got from 𝐂𝐞.com. You go to 𝐂𝐞.com and just type COVID-19 detection dataset. You will get a bunch of data. In that, from one of the data, I picked a lot of X-rays and I have put all that in my Google Drive link. So let me show you that first. This collab datasets. So I'll just show you image. So I have put two data sets. One is for training, another is for validation. Always remember, in any machine learning algorithm, there are two parts. One where you train your model. Model is nothing but your program. Where you train your model, that means you will get some set of data to it so that it is prepared. Okay. Once it is prepared, in order to validate whether this is doing or not properly, you will keep another set of data. That is your validation data or your testing data. So I have valid training data which says about what how the COVID X-ray looks like and how the normal X-ray looks like. Similarly, for validation also I have two data sets, one for COVID data, another for normal. So if we look at COVID, I have a lot of images. So you see this one, this is a COVID X-ray. Let me see if I can zoom it. So this is a COVID X-ray. Okay, the COVID patient X-ray, this is how it looks like. Now, similarly, if you look at normal, I also have got certain data on it. This is a normal how a patient looks like when you don't have a COVID symptoms like that. So using this data, what I am supposed to do is I'm going to train my model, and after training it, and it should be able to tell me if I give a new data. That means if I pass a new data to it, it should be able to tell me whether it is a COVID-19 patient data or you know it's a normal patient without any COVID symptoms. I mean, they don't have a COVID kind of. That's the whole idea here. Okay, let me take this out here. Okay, so I just imported set of libraries, NumPy, Matplotlib. I need some for visualization. Keras is the library I'm using here. So Keras, I'm using this convolution neural network and all that, and all the things which is required. Data set, if you want, I can directly show you. That link I can give you directly. I just went to 𝐂𝐞.com for the data set. I'll just show you what I did. I went here and I said COVID-19 data set, and you can pick any data which has this X-ray information and all. COVID-19 data set. This is what I did. And you see, I just picked the first one, this one. The same data set is what I picked. You just need to download. I'm just sharing this because it's public. So now what I do is the same data set I have uploaded in my Google Drive in order to show you guys this. So given that we are here, no problem. Okay, now I ran my model, ran all the libraries so that all the my libraries are installed. Now I'm telling this guy how my image data generator should be. I'm telling how you should rescale and all those parameters. Then for training, I'm telling this guy from where to pick it. So I gave my Google Drive location. So if you see my Google Drive location, if you observe closely, it's very dead easy to pick. Google offers a lot of flexibility where you can say where is your training data. All you need to do is just do it and just say copy path, and that is the same thing I have copied here. Okay, so it's very simple once you put in Google. After that, I'm saying I want a 256 by 256, and I'm saying it should be a binary classification. You have to say yes or no. Then once I ran it, this is my training data. And training data, it gives me, since I asked binary, it gives me saying whenever I give answer as 0, consider it as COVID patient. Whenever I give answer as 1, consider it as normal patient. Okay. Now this is a test data. That means once I train it, I have to validate whether it is good or bad, right? So this is that guy. So I tested it. I put the test data also, and I'm giving the test data also here. Now here is where I'm creating my model. So once I created it, I'm running. So now once I run it, it does a lot of things. Like I showed you that pooling and all, you can see those terms, pooling, the filtering, the activation, everything happens. So activation here, I'm using ReLU as well as I'm using sigmoid also. There are different activation algorithms. So I used two things here. And finally, when you run it, you get a summary of what is it. So it says it started with 896, then 18496. So you see each time the output shape if you observe this, it's getting decreased, right? So it is actually tries to converge so that it gives a better image and better perspective of it. Now, since I trained my model, now I asked based on the data I trained, now you start learning. This is where I use to say that, okay, you start learning now. Now I said, okay, this is your training data. You have to run it 10 times and each time 8 epochs, and it starts running now. So you see what the thing you have to observe is this accuracy. This accuracy you're saying, right? You have to see that. If you are getting accuracy of, let's say, 90%, that means it is very good, 90% and above. In fact, from this data, I was not able to get it. I got something around 61 or 62 and all, but still I was able to predict good. So it says now 0.7, which is 70 percentage. Now it says 75. So it all depends. So convolution neural networks, if you look at deeply, one of the disadvantage with the convolution networks is it needs lot of data. It needs lots and lot of data. The more data you give, the better it gets trained. And one more problem with convolution networks is because of it, it has to learn from a lot of data. It takes a lot of time also to get trained. Okay, that's actually one reason why I didn't run more than 10 steps, because it takes time. Okay, but whereas if you look at ANN, which is the first model we showed in there, even with limited data set, it will work. But it might not able to predict as good as this guy, that is always there, but this guy takes a lot of time and he needs a lot of computation also for CNN if you are training it for so much data, because the data, it needs a lot of data. That is the biggest disadvantage here, whereas ANN can work with limited data set also. So you have to make a choice based on your requirement whether you have to use CNN or ANN based on the data set you have. So you see, it started with 0.5, it went with 70%, 40%, then 70, then 80, then 50. So I might still need to run for some more, but let's see with this 50% we are able to train our data or not. Okay, so my accuracy is only 50% now. Now I'm giving first the COVID image. This is my COVID image. I just picked one of the COVID image. This is my validation data. You see the val I put. So val is coming from here. So I just gave one of the COVID. I just picked one of the image from this, a random image, and I have to see whether it really tells me the answer whether it's COVID or not. And here I'm loading. These are all image libraries. Here I'm saying, okay, this is your image library, and the path of this is this, which is nothing but this COVID patient thing, and I'm converting to array and all, because the expectation of this library is you have to give it as a numpy array. So I gave it, and this is where I'm asking it to predict. Let me run this guy. Let's see. And if I run that, now if I run this, it says 0. I could have put more if condition and all, but since the model is, we are getting we are getting 50%. Let's see. So 0 means what? If you look at here, I already told you 0 means COVID. So it says it is a COVID patient with 0. So have we given the 0? Have we given a COVID patient data here? Yes, we have given a COVID patient. You can see it is a COVID image, COVID patient image. Similarly, let's try for normal. Okay, so it is able to detect a COVID patient properly from the image I gave randomly. Now this is my normal image. I picked it. So this is the normal image of the person who don't have a COVID. Now let's train it. So it says 1. So 1 means what? It is normal. That's what it has told here, right? 1 means normal. So even with 50% accuracy on the data, it is still able to infer good results, right? Even with 50% accuracy, it is able to tell me based on a random image I throw to it, it is still able to tell me whether it is a COVID patient or a normal patient. In fact, what I can do is based on this, I can just put an if condition. This is just an numpy array, right? I can just put a if condition and say if it is 1, just say COVID patient, normal patient. If it is 0, just say COVID. All that I can do. It's just a code part of it. Okay, so this is how you can train your model and do it. In fact, accuracy of it I can even improve a lot. It is now 50%, but 50% also it is able to infer correctly for any random image I throw to it, but might not be guaranteed because it is 50-50. Maybe if I give you a completely different data altogether, it might get confused also. So it might need a lot of training. Maybe I need to train it for, let's say, another 1 hour or so that it gives accurate data. Okay, this threshold, actually why I use threshold is, actually there used to be a function earlier as part of the keras also, where the function name is predict generator, something like that. That is deprecated now. that function is deprecated. So since it is deprecated, what I did is first I predicted the model. There is a function only called predict. Earlier there used to be predict generator, which automatically gives me this answer. Since that function is not there, what I did is I just predicted it, and that prediction result is something like this. What I did is model.predict and image, and that gives me answer like this. Now based on this image, I have to, based on this value, I have to tell whether it is a COVID or not. So what I did is I'm just producing this np.where is nothing but I have put a threshold. The threshold indicates 0.5. So what I said is any value which is more than 0.5, give the value as 1. Any value which is less than 0.5, give the value as 0. So if I run this for a normal patient, you see 0.55, and I have put a threshold, any value more than 0.5, then only it will consider 1. 1 means normal patient. If it gets less than 0.5, that means 0.50, then it will say 0. That's the condition I have put using numpy query. That's it. Since we do not have the function earlier, that function used to be there which directly produces it, I have to do all that. That's it. I'm done for today. I think you guys at least get a sense of what is neural network and what we are doing here, and how it helps actually to do some kind of deep vision and infer something. And we'll meet again if we have any session like this. See you all. Good day.